Welcome learners. In this session we are going to learn about convolution theorem. Before that we have to know about convolution of two functions. If f of t and g of t are two different functions, then convolution of f of t and g of t is given as f of t star g of t, which is equal to integral 0 to t f of u dot g of t minus u into du over the interval 0 to t. Here, f of t star g of t can also be written as g of t star f of t. Now, convolution theorem statement. If f of t and g of t are two different functions defined for t positive, then Laplace transform of f of t star g of t is equal to L of f of t dot L of g of t. Here, by making use of inverse Laplace transform, Laplace transform of f of t star g of t is equal to f of s dot g of s. We know that. By taking inverse Laplace transform on both sides, we'll get L inverse of f of s dot g of s equal to f of t star g of t. Already we know that f of t is the inverse Laplace transform of f of s and g of t is the inverse Laplace transform of g of s. Now, we have to understand some important formulas and keep it in our mind. Integral of e power ax into dx is e power ax by a. Integral of sin ax dx is minus cos ax by the coefficient of x, which is a. Integral of cos ax into dx is sin ax by a. Integral of e power ax sin bx into dx is e power ax by a square plus b square times a sin bx minus b cos bx. Integral of e power ax cos bx into dx is e power ax by a square plus b square a cos bx plus b sin bx. Also, the well-known trigonometry formulas gives you sin a cos b equal to 1 by 2 times of sin of a plus b plus sin of a minus b. Cos a cos b equal to 1 by 2 times of cos of a plus b plus cos of a minus b. Sin a sin b equal to 1 by 2 times of cos of a minus b minus cos of a plus b. Now we'll move on to the problem. Find L inverse of 1 by s cube times s plus 2. Here I am going to write this product of two terms as L inverse of 1 by s power 3 into 1 by s plus 2. This we can write it as L inverse of 1 by s power 3 star L inverse of 1 by s plus 2 by making use of convolution theorem. We know that by convolution theorem, we have L inverse of f of s dot g of s is equal to f of t star g of t. This is going to be the convolution of two functions definition f of u dot g of t minus u into du. So by making use of this definition theorem statement, we are going to have f of t as equal to L inverse of 1 by s power 3. So this equal to L inverse of 1 by s power 3. By making use of the formula, you will get t power 2 by 2 factorial, which is 2. Okay, and here in the formula, we are having integral 0 to t f of u. So I'm going to take in terms of f of u as put t equal to u, you will get u squared by 2. Likewise, we are going to find what is g of t. G of t we have considered as L inverse of 1 by s plus 2. So this equal to e power minus 2t, we know that. So g of t minus u will give you e power minus of 2 into t minus u. This I can split it as e power minus 2t into e power plus 2u. Okay. Now we are going to substitute in the formula. So here this I can write it as what? F of t star g of t. So in this place I am going to substitute the formula. Therefore L inverse of, so according to the first equation, L inverse of 1 by s cube into s plus 2 can be written as, okay, integral 0 to t f of u is u square by 2 times e power minus 2t into e power 2u into du. So take, when you are doing the integration with respect to u, okay, you have to treat t as constant. You can take e power minus 2t by 2 as constant outside, integral 0 to t u square times e power 2u into du. Now, by making use of integration by parts or Bernoulli's formula, you will get here Bernoulli's formula we are going to make use of. That formula states that integral of u v into dx is equal to u into v1. V1 means integral of dv, okay, minus u dash into v2, that is differentiation of u with respect to x, and integration of v1 with respect to x is v2. Likewise, you have to do the differentiation and integration, okay, until the term gets terminated. So here we are going to take u as u square, the term which going to be terminated while doing the differentiation. Okay. So we are going to take u as u square and integral of dv as e power 2u into du. Okay. So we are going to get e power minus 2t by 2 multiplied by u square into integration of e power 2u is e power 2u by 2 minus differentiation of u square is 2u multiplied by, again integration of e power 2u by 2 is e power 2u by 4, then plus differentiation of 2u will give you 2 into 1 into integration of e power 2u by 4 will give you e power 2u by 4 into 2 is 8. Then next term is going to be 0 because we are going to differentiate 2. So we are going to stop it here. Then after that you have to put the limit u equal to 0 and u equal to t. After substitution, you can check it. So here e power minus 2t by 2 into, put u equal to t, you will get t square into e power 2t by 2. Okay. When you are putting the lower limit, it will be minus 0. Then minus 2u, that is u equal to t, into e power 2t by 4, and by putting the lower limit u equal to 0, you are going to get 0 plus 2 into e power 2t by 8 minus, okay, when you are putting u equal to 0, you will get 2 by 8. So here, doing the simplification, you will get e power minus 2t by 2 into t square into e power 2t by 2 minus 2 gets cancelled, t into e power 2t by 2, okay, plus here 2 times of e power 2t by 8, that will give you e power 2t by 4, okay, minus 1 by 4. So you can see that integration of 0 to t, okay, the function u square by 2 into e power minus 2t into e power 2u into tu gives you the answer as like this. Here we have used the Bernoulli's formula. Okay, the term you have to choose the function which gets terminated while doing the differentiation. Okay, if the term you are choosing for u, if it does not get terminated, you can't apply this formula. Okay, you have to use the standard integration formula alone. That is, I'm saying that if you are having the integrals integral e power ax sine dx, in that case you can't apply this Bernoulli's formula. I think you are able to understand it, I think. Okay. So now next we'll see the next problem. Using convolution theorem, find L inverse of s square by a L inverse of s square by s square plus a square the whole square. So here how we are going to solve it. Okay. Now L inverse of s square by s square plus a square the whole square. You can write it as L inverse of s by s square plus a square times, okay, s by s square plus a square. So this I can write it as L inverse of s by s square plus a square star L inverse of s by s square plus a square. Now what is this equal to? This is cos 80 star cos 80. Now which is going to be taken as f of t star g of t. So what is this integration? This is equal to integral 0 to t f of u into g of t minus u into du. Therefore, we are going to consider integral 0 to t cos au into cos of a into t minus u into du. That is, in the place of t, we are putting t minus u. So it is equal to, here you can make use of cos a, cos b formula. We understood that cos of a plus b into cos a into cos b equal to 1 by 2 times of cos of a plus b plus cos of a minus b. So make use of that formula. Here you are going to have integral 0 to t cos of au plus at minus au plus cos of au minus at minus of, okay, so plus au into du This is into 1 by 2. So which is equal to 1 by 2 times of integral 0 to t. AU gets cancelled. Cos at into du. I am splitting the integration plus integral 0 to t cos of 2 times of au minus at into du. Now what is the integration of du? It will be u itself plus integral 0 to t cos of I can take it outside 2u minus 8 minus t you will get minus t into du. This gives you 1 by 2 times of cos at. Put u equal to 0 and u equal to t plus integration of causes sine a into 2u minus t by coefficient of u. You are integrating with respect to u, so it is 2a. Put the limit u equal to 0 to u equal to t. Already I have given the formula for integration of cos ax as sine ax by a. So by making use of that formula, we are getting this. Now 1 by 2 times of, when you are putting u equal to t, you will get t cos at plus 1 by 2a into, put u equal to t, you will get sine of, 2t minus t, so t at by 2a. Then put u equal to 0, you will get it as sine of minus 80. That will give you sine of minus theta is minus sine theta. Already we are going to apply the lower limit. So it is plus sine 80 by 2a. Sine of minus theta is minus sine theta. So for u equal to t, you will get 2t minus t, that is gives you 80 by 2a, and put u equal to 0 here, you will get minus t. So sine of minus 80, already it is a lower limit, so minus of minus sine 80, that gives you plus sine 80 by 2a. Now by doing the simplification, you will get 1 by 2 times of t cos at plus, 2a is common, so you can take it outside, 1 by 4a square into 2 times of sine at. Therefore, it is equal to t by 2 cos at plus, 1 by 4a square sine at is the answer for L inverse of s square by s square plus a square. I think this helps you to understand how to solve this convolution theorem problem. Okay, we'll see you in the next session.